Welcome to Excellential School of SCE. Now, here are the questions. The two solutions we're dealing with are sodium carbonate and H2SO4. This is the question, the statement of the question. And we have to find the concentration of A. I will go straight to the solutions so that we conserve time. Okay, we have the table. This is how the table looks. Volume of pipette is 25 cm3. Now, ensure you arrange your table correctly, like this. Do not forget the units. Do not forget the volume of pipette. And then here, you must not have 0.00 origin. I decided to have. You can have anything, but just make sure your table is clear. And then we have the first question here says that you should tabulate your reading and then find the volume of the average volume of A used. And this is the average volume of A used. You present it in 2 decimal places, as you can see here, with the correct unit cm3. Now the second question here says that you should calculate the concentration of A in mole per dm3. Concentration of A in mole per dm3. And here is it. When you go back to the question, you see that you were told that it contains 1.28 gram in 250 cm3. So you have to convert it from 1.28 grams in 250 cm3 to find the gram in the concentration in gram per dm3. So you make the statements like this. If 1.28 is found in 250 cm3, how many grams will be found in 1000 cm3? Of course, 1000 cm3 is 1 dm3. Making X the series of formula, we see that the mass concentration is 5.12 gram per dm3. Of course, you have to find the molar mass, okay, the molar mass of the substance. The molar mass is as stated here. Okay. And then we have, again, this is the, so having this now, the molar concentration is N is equal to M over M. And substituting here, N is equal to 5.12 over 98, which is equal to 0.0522 mole per dm3. Take note of the correct unit and take note of the 3 significant figures. Please let your concentration be in 3 significant figures. And then we come to the second question. The second question says concentration of B in mole per dm3. Concentration of B in mole per dm3. And we use CAVA over CBVB is equal to NA over NB. And before we substitute, we make CB the subject of formula. And the CA we're going to use is the concentration of A here in mole per dm3. So having made CB the series of formula, we substitute accordingly. Okay, the ratio of A to B in the balanced chemical equation is 1 to 1. Here is the balanced chemical equation, is 1 to 1. So you find that CB is 0.0386 mole per dm3 in 3 significant figures. And the next one is concentration of anhydrous X2CO3. That is in gram per dm3. Anhydrous B in gram per dm3. We use the formula N equals to M over M, and we are looking for M. We make subject of formula before substituting, and the question already gave us the molar mass of anhydrous B. Okay, yes, the molar mass is 106. So we use this is the molar concentration. Yes, the molar mass, there is the relative molecular mass rather of anhydrous B, and this is the molar mass, molar of B. So substituting 0.0386 times 106, okay, which gives us 4.09 gram per dm3 in 3 significant figures and the correct unit. And the next question here says, the next question here says the value of the relative atomic mass of X. Okay, we have it that X2CO3 is equal to 106. So we want to make X the subject of formula. That is the whole operations that was carried out here, and you find that X has the value of 23. Obviously X should be sodium, but it's not stated, but we found that the value is 23. The next question says find the value of Y, that is water of crystallization, in the hydrated salt. Find the value of Y. So we make a simple statement. You see the ratio of the anhydrous to the hydrated is 1 to 1, okay? Which means that we can relate their mass concentration. The mass concentration of the anhydrous, which we've already calculated up here, we've already calculated this is 4.09 grams per dm cube. And the question told us that the solution contains 9.65 grams per dm cube. Having noted that, we have to, that is back here, we have to relate them. Okay, if 4.09 is related gram per dm cube for the anhydrous, of course, gave us or came from 9.65 gram per dm cube of the hydrated salt or portion of the sample. Then it means that 106 grams of the anhydrous substance should be related to Z. Okay, Z gram. We make Z the subject of formula by cross multiplying. We cross multiply and make Z the subject of formula, as you can see it here. So we see that the molar mass of Z is 240.94 gram per mole. If you are told relative molecular mass, please forget the unit. Do not forget to take note of that. And so, okay, here, therefore, X, all this is equal to this, because we have the anhydrous is this, and when you calculate the anhydrous plus Y water of crystallization, it gives us everything is okay. The value here, sorry, there was a mistake here. The value here should be 250.1 gram, okay, per mole. And having noted that, we have to make Y the subject of formula, collecting like terms and making Y the subject of formula. We find that Y is 8. It must be corrected to the nearest whole number, 8. And the next question says the percentage water of crystallization. Okay, percentage water of crystallization. And then we have to use sorry, this should be, we have to use this is the anhydrous, this is the water of crystallization, and this is the molar mass, okay, of the hydrated substance. So when you do water of crystallization over molar mass of the hydrated substance times 100/1, the percentage water of crystallization would give you 59.81%. And finally, we are told to calculate the volume of carbon dioxide that will be evolved from B. You check from the question, 1 mole, the ratio of carbon dioxide to B is 1 to 1, which means that 1 mole of B will give you 1 mole of carbon dioxide, which is 22.4 dm cube, okay? Because 1 mole of every gas occupies 22.4 dm cube. Therefore, that is the molar conc of the hydrated substance would give 0.0386 times 22.4 or 1, which is 0.865 dm cube. That is it. So thank you very much and best wishes. Don't forget to subscribe to this channel if you are new.